Lesson 10 is coordinate proofs in the distance formula, and in 10.1 we're going to prove that a quadrilateral is a parallelogram using the distance formula. So in order to do that, we just have to show that the opposite sides are congruent to each other. So if the opposite sides are congruent, that means that we have a parallelogram. So the distance formula is going to help us show that each opposite side is congruent. We just have to find the distance between the vertices. So distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And then the other important thing to know is that when like a quadrilateral is titled or like given a name, in this case A, B, C, D, it's ordered like that on purpose, and it helps you figure out what vertices you actually find the distance between. So like we'll go from A to B, and then from B to C, from C to D, and then from D to A. We wouldn't have to find like A to C because those are not consecutive, or like B to D because those are not consecutive. Okay, so given the quadrilateral ABCD with vertices at A, which is negative 5, 4, B, which is 1, 4, C, which is 0, 1, and D, which is negative 1, 6, we want to prove that ABCD is a parallelogram. So for our proof, we're just going to start with what we're given. Same statement is quadrilateral ABCD with those vertices, and our reason is that it's given. And if we want to be able to prove that this is a parallelogram, we have to show that those opposite sides are congruent to each other. So we can show that using the distance formula, like actually finding the length of each side. Okay, so for the distance formula, I'm going to find from A to B first. So I'm going to say that A is my like 0.1 and B is my 0.2. So the distance formula, let's see, so x1 will be negative 5, y1 will be 4, x2 will be 1, y2 will be 4. So it's the square root of x2, which is 1, and then minus x1, which is negative 5. So 1 minus negative 5 squared, and then plus y2, so 4, and then minus y1, which is also 4. So plus 4 minus 4 squared, and then now we can simplify. So inside the first set of parentheses, 1 minus negative 1, if you have a double negative, that turns to a plus. So it would be 1 plus 5, so that would be 6 squared. And then plus over here we have 4 minus 4, which is 0 squared, so that's just 0. So we don't need to like add 0 because it doesn't make a difference. So this would just be 6 squared, or the square root of 6 squared, which if you are taking the square root of a number that's squared, they just cancel each other out, so it would just be 6. Another way of thinking of it is like you could actually like square 6 and get the square root of 36, and then if you square root 36, you would get back to 6. So whatever is more comfortable for you. And then I'm going to find from B to C next. So we'll set up our square root, and then I'm going to go through and label each point. So we'll say, it really doesn't matter which one is which. I think I'm going to keep B as like my 0.2. C will be my 0.1. So this will be x2, y2. This will be x1, y1. So x2 minus x1 will be 1 for x2, and then minus 0 for x1. So parentheses 1 minus 0 squared, and then for my y's, y2 is 4, and then minus y1 is 1. So it'd be 4 minus 1 squared equals the square root of 1 minus 0 squared. That would just be like 1 squared, so just 1. And then 4 minus 1 is 3, and then we got to square the 3 to get 9, so it'd be plus 9. So this would be the square root of 10 altogether. And then the square root of 10 can't be simplified, it doesn't have any like perfect square factors, so we would just leave it like that. And then we can move on to CD. So we'll do CD next, set up our radical, and then I'll go through and label each point. I'm just going to keep like my points labeled for C, because might as well. And then for D, that'll be my 0.2. So this will be x2, y2. So starting off with x2 will be negative 6 minus x1, which is 0. So negative 6 minus 0 squared. And then plus for my y's, it'll be y2, which is 1, minus y1, which is also 1. So plus 1 minus 1 would be 0. And then equals, I have a like negative 6 minus 0, that's negative 6 squared. And then 1 minus 1 is 0, and 0 squared is still 0, so I don't need to add that in. And then now, this one's a little bit funky because you can't just like say that the like squareds cancel each other out, or like the square and the square root. So this one I am going to go ahead and simplify the like negative 6 squared. So negative 6 squared is negative 6 times negative 6, so that's 36. And then the square root of 36 would be 6. Either way, it's just when you're square rooting it, like the outcome would have to be positive, especially because this is like a distance, and distance would always be positive. Okay, and then next we'll do, so we've done A to B, B to C, C to D, and then now we just need to do D to A, so those last two. So D to A, set up our radical, and then we'll label our points. So I'll just say that A is 0.1, so I can keep my labeling on D. So this will be x1, y1. So for x2, it'll be negative 6, and then minus x1 will be negative 5. So parentheses negative 6 minus negative 5 squared, and then plus, for my y's, y2 minus 4. Sorry, y2 is 1, and then minus y1 is 4. So 1 minus 4 squared. And then in the first parentheses, negative 6 minus negative 5. If you have a double negative, it turns to plus. So negative 6 plus 5 would turn into a negative 1. And then we still have to square that. Negative 1 squared would be 1. And then in the second parentheses, 1 minus 4 is negative 3. And then we still have to square that. So negative 3 squared would be negative 3 times negative 3, which is positive 9. So 1 plus 9 would leave us with the square root of 10. And again, that can't be simplified, so we would just leave it as is. Okay, so we ended up with AB is 6, B to C is root 10, C to D is 6, and D to A is root 10 as well. And to find all of those, we just use the distance formula, so that's going to be our reason. Okay, and then moving down to 3, we want to kind of start to set up to be able to say that these lines are congruent. These are just distances. The way that they're written for like 2 is they're just distances. Like the distance between A and B is 6, B to C is root 10, and so on. So now we can start to kind of pair up the distances between each of the points. So like from A to B is 6, and from C to D is also 6. So we can say that the distance between A and B is equal to the distance between C and D because those are both 6. And then the same thing with like B to C and D to A. So the distance from B to C is root 10, and the distance from D to A is also root 10. So we can say the distance between B to C and D to A are equal to each other because they're both root 10. And that's using something called the transitive property of equality. And the transitive property of equality is if x is equal to y and y equals z, then x is equal to z. So since like I'll use A and B and C to D in this case. So since A and B is 6 and C and D is also 6, then A and B must also be, or sorry, A to B must also be equal to C to D. Okay, and then now that we've said that those distances are equal, we can go ahead and say that those line segments are congruent to each other. So we can say A to B, or segment AB, is congruent to segment CD. And then we can also say segment BC is congruent to segment DA. And that's because after we've stated that their distances are the same, like are equal to each other, that's the definition of congruent segments. So that's going to be our reason for part 4. So definition of congruent segments is that they have like the same distance between their endpoints. And then now we said that the like opposite sides are congruent to each other, and that's one of the things that we could have used to prove that this was a parallelogram. So we just need to wrap up our proof. We can say that ABCD is a parallelogram, and the reason is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so moving down, this next little part is just a few notes on like different ways that you can prove that a parallelogram is a parallelogram. So when writing a coordinate proof to show that a quadrilateral is a parallelogram, prove one of the following. You don't have to do all of them. It's just these are different like kind of strategies we can take. First part is that both pairs of opposite sides are parallel. We've done that in the past using the slope formula. So both pairs of opposite sides are parallel. The next one is the one we just did, proving that both pairs of the opposite sides are congruent. That's the distance formula. The third one, prove that one pair of opposite sides are parallel and congruent using the slope and the distance formula. So you'd have to use both, but it'd just be for one pair of sides instead of two. And then the last one, prove that the diagonals bisect each other using the midpoint formula. And the diagonals are like going from opposite kind of vertices, so it would be like A to C or B to D. Okay, so moving down to 10.2, this section is focused on circles. So I want to review the like formula for the standard form of a circle. It's x minus h squared plus y minus k squared equals r squared, where I didn't type this in, so I'm going to add it right now, but the center, all you see, is the point HK. And then, of course, like r is the radius of the circle. Okay, so example 1, the equation that represents circle A is x plus 1 squared plus y minus 1 squared equals 16. Determine whether the point B31 is on the circle. So there's a few ways of doing this. If you have a circle, it bugs me when it doesn't change. So if you have a circle, say center at point A and point B is on that circle, then the distance between A and B should be the same distance as like the radius, or should be the same length as the radius. So you can find the center of point A from this equation, like finding H and finding K, and then find the distance between the 2 points and see if that's the same as the radius, which the radius should be 4, because this is 4 squared, right? It's not like that number isn't exactly the radius. That radius is the radius squared. So the radius should be 4. But I think that kind of takes a little bit longer than it needs to. So I'm going to show you an alternative way. Okay, so this equation is supposed to represent any point on the circle. So if that's true, it is the equation of the circle. If this point 3,1 is on the circle, we should be able to put it in the equation and get like a true statement out. So that means that we're going to take 3 and put it in for x and 1 and put it in for y. And if it makes the equation true, then yes, it's on the circle. And if not, then no, it's not on the circle. So we'll put 3 in for x plus 1 squared. Everything else is staying the same in the equation. So 3 goes in for x. And then plus 1 is going to go in for y. So 1 minus 1 squared equals 16. We'll add both of the parentheses. So 3 plus 1 is 4 squared. 1 minus 1 is 0 squared equals 16. 4 squared is 16. 0 squared is 0, so it doesn't make a difference. And then equals 16 over here. So that's true. So that means that yes, that point 3,1 is on the circle. So B31 is on circle A. For example 2, point A42 is on circle C, which has a center at C, which is 0, -5. And we want to see if point B and point D are both on circle C. So there's a few different ways that we can do this problem. One way is to find the radius of the circle, which if we know that point A is on the circle, then we can find the distance between point A and point C, and that'll give us the radius. If we go that way, we can write the equation of the circle and do it exactly like example 1. It would be, the rest would be the same. But I want to show you a little bit different way. So One is just by kind of like focusing in on the formula or the part of the formula for the circle that involves the center and the points x and y. So just the x minus h squared plus y minus k squared. I'm not going to worry about the r squared for right now. So first I'm going to do is I'm going to take the center and put it in for h and k, because like the center is supposed to be the point h, k. So that means that h is the x coordinate from the center and k is the y coordinate from the center. So I'm just going to copy down that left side of the formula for now. So it'll be x minus h squared and then plus y minus k squared. So h is going to be 0, k is going to be negative 5. So I'm just going to take that h out and replace it with 0. And then take that k out and replace it with negative 5. Okay, and then I have a y minus negative 5. We would never leave the double negative in there, so I'm going to change it to a y plus 5. So then now this gives me kind of like the, not the full equation, but a part of the formula for the circle, or part of the equation for the circle that involves the center. And then for the next step, I'm going to take that equation and just put, or I guess that expression, and just put in the point that I know is on the circle. So I know like the point A, which is 4, 2, is in the circle or on the circle. So I'm going to put 4 in for x, and then I'm going to put 2 in for y, but I'm going to do it in another step. So 4 is going to go in for x, so it'd be 4 minus 0 squared, and then plus 2 is going to go in for y, so it'd be 2 plus 5 squared. I'm going to erase that h and k and move it up above. Okay, so we have 4 minus 0 squared because we put that 4 in from like point A, and then plus 2 plus 5 squared, we put that 2 in from point A as well. So this we know is like for sure a point on the circle and for sure the center. So we're going to use that equation kind of like, or that expression kind of as like a key. And the reason I'm doing it this way is because like you'll see like once you kind of get into like the problems in the test, problems in the workbook, they ask you for this like initial setup step. So it's going to be really important to understand it. So I'm going to keep that part that's highlighted in yellow and use it as a key. And then every other point that I'm checking, so like point B and point D, I'm going to put them into this part of the formula because that's the one that has the center in, but I can put any x and y that I want. So I'm going to create kind of two sides to the equation. One is going to be the key side, so I'm just going to take this and copy it down as is. And then one is going to be the side that has like just the center, but has the room for me to put in that new point. So it has the x and y in there for me to put in the x and y from point B. Okay, so for point B, x is going to be 4 and y is going to be negative 12. So we'll put those in there. So it would be 4 minus 0 squared plus negative 12 plus 5 squared equals 4 minus 0 squared plus 2 plus 5 squared. Okay, so what this is doing is it's taking like the bulk of like the standard form of the circle and setting them equal, because what all of this equates to is like the radius squared, is r squared. So they should have the same value on each side if both points are on the circle, because they should have the same radius no matter where the point is on the circle to have the same radius. So this is kind of the part of the problem where you'll have to be able to like identify what is the correct initial setup and then simplify to prove that they actually are equal or they are not equal. If they are equal, then the point will be on the circle. Okay, so we'll subtract 4 minus 0 is just 4, and then plus Negative 12 plus 5 is negative 7 squared. 4 minus 0, 4 squared, plus 2 plus 5 is 7 squared. So 4 squared, 16, plus negative 7 squared is 49, because it's negative 7 times negative 7, equals 16, plus 7 squared is 49, so another 49 right here. And then you can start to see that it is going to be equal, but we'll just kind of finish it out. 16 plus 49 is 65. So we ended up with 65 equals 65. So that means that this is a true statement. So that means that, yes, point B is on the circle. So yes, point B is on circle C. Okay, and then we're going to do basically the same thing, but just check a new point. So we'll take that part of that expression that is highlighted in yellow. That's going to be our key. And that's our key because it has the center in and it has a point 4, 2, which we know is on the circle. So you take the point that you know, or the expression with the point that you know, and use that kind of as the key. And then now we take the part of the formula that just has the center in there, because the center is not changing. The points that are changing are like the ones that we are checking, and those are going to go in for X and Y, not for H and K. So if we want to check point D, let me erase some of this highlight. So if we want to check point D, we have to put point D in for X and for Y. So we'll put negative 3 in for X and then 5 in for Y and simplify. So it'd be negative 3 minus 0 squared plus 5 squared equals 4 minus 0 squared, and then plus 2 plus 5, so 2 plus 5 squared. Okay, so again, this is like the initial setup that some of the multiple choice problems will be looking for you to like identify which is the correct one. So we want to be able to show that setup, and then you would simplify to see if it's actually a true statement. So negative 3 minus 0 is negative 3 squared, plus 5 is 10 squared, equals 4 minus 0 is 4 squared, plus 2 plus 5 is 7 squared. And then negative 3 squared means negative 3 times negative 3, so it'd be 9, plus 10 squared is 100, equals, this is going to end up simplifying the same way as the previous one, the right side, because it's the same thing, but 4 squared is 16, plus 7 squared is 49. We know 16 plus 49 is 65, and 9 plus 100 is 109. So that one is not true. So we would say no, point D is not on circle C. Okay, so looking at this problem as a whole, so the very first part, this guy right here, we're able to use that kind of as like a key or like a checking point because it had a point that we knew was on the circle, point A, and the center. So we check it against the points that we don't know are on the circle, B and D in this case. And if they end up being the same value at the end, like how we ended up having 65 equals 65, that means that that new point is also on the circle because they're essentially the same distance from the center. And then if they don't have the same value, that means that that new point is not on the circle because it has a different distance from the center than a point that was already on the circle.